like they're starting off with some algebra.
Yep.
This isn't really geometry, but that's good. Actually, I'm glad to see them do that. So, shall we start at the beginning?
Sure.
There was a closer beginning here. Hold on a minute. Let me write this one out. 4 root 6 times 3 root 15. Now, whenever you're multiplying square roots, you can always say that the square root of 6 times the square root of 15 is the square root of 90. Okay?
Mm-hmm.
However, that may not be the best way to go. In other words, you kind of have to look at these a little bit like they're a puzzle. I could make it certainly 12 square root of 90. See how I get to that point?
Mm-hmm.
But now I got to simplify square root of 90.
Yeah.
So I have to find factors of 90 that has a perfect square. And I don't think I can do that. Let's see, 90 and 1, 45 and 2, 15 and 6, 5 and 18. None of those are perfect square numbers. So in terms of simplifying this, I can't really by traditional means simplify it. However, hold on a second, let me go back and look at the original. And let's break it down first. In other words, let's make square root of 6 square root of 3 times square root of 2. Normally I wouldn't do that. In other words, normally I would only simplify it if I can pull a whole number out.
Mm-hmm.
But in this case, now let's make root 15 the square root of 3 times the square root of 5. Now notice that I've got square root of 3 times square root of 3. So I actually was able to pull out a whole number. In other words, I have 4 times 3, square root of 3 times square root of 3 is 3. So I have 4 times 3, which is 12, times 3, which is 36. And then I have square root of 10, which is the square root of 2 times square root of 5. So that's definitely simpler than I originally had. Although, let's go back and look at the way I did it originally. I actually forgot 2 factors of 90, which are 9 times 10. And the square root of 9 is a whole number. So I could take a 3 out, multiply it by the 12, and I get 36 times square root of 10. Same answer. And actually a little bit quicker. In other words, when I multiply the 6 times the 15, I can reduce it a little faster than if I do it the second way. You get to the ultimate answer, and the ultimate answer is this one right here, the bottom thing circled. It's just a question of how you get there. And it turns out, really, the simplest thing is to multiply the 6 times the 15, you get 90, and then you split the 90 up that way there.
Okay.
That, to me, seems the fastest way to do this. And let's use that system on the next problem. In other words, the next problem is 2 square root of 3 times 5 square root of 12. Well, let's just multiply everything together. What do you get? Multiply the whole numbers. What do you get?
10.
And multiply what's inside the radical. What do you get?
36.
That's a whole number. So what's the final answer?
10
Times
6.
60.
Yeah.
Okay. So it seems like that system really is kind of the way to go. Although when you get into bigger numbers, it may not be true. In other words, when I'm doing this problem, now I either need to get a calculator out or something because I don't know what 14 times 21 is. I can do it manually, but let's try breaking it down a little bit first, and that way I can avoid having to get a calculator out. Okay, so what should I make 12 root 14 equal to? In other words, can you split that up? Even if you're not pulling out a perfect square, it might be worth it to split it up in this particular problem. Square root of 14 is equal to what?
3.74.
Well, 2 times 7, right? So it's the square root of 2 times the square root of 7.
Oh. Yeah.
Now I'm going to multiply that by 7 and break up the square root of 21 into 2 factors. What are factors of 21?
7 and 3.
Now notice what I can do. I've got a square root of 7 there, and I've got a square root of 7 there. Everything is being multiplied together, so what's square root of 7 times square root of 7?
7.
So now I have 12 times square root of 2, and I'm going to combine those two to make 7. Then I got another 7, and I finally have that square root of 3. We'll multiply all the whole numbers together. You get 12 times 49. And that's 588. Then square root of 2 times square root of 3 is square root of 6. So that's the answer to that one.
Okay.
Now, had I multiplied 14 times 21 together, I would have gotten 294. In other words, if we do it a different way, I get 12 times 7 times the square root of 294. Now, the problem with this answer is the bigger that these numbers get that are inside the radical sign, the harder it is to simplify. I don't know factors of 294. Okay? So it's going to be extra difficult to convert this answer here to make sure it's the same as that answer there. I mean, really difficult. Reducing the square root of 294 is not easy. Well, notice that the way I did it, I never had to do that. I immediately reduced it from the get-go. I did this problem differently than I did the first two, in that I reduced square root of 14 immediately to square root of 2 times square root of 7, and I reduced square root of 21 immediately to square root of 3 times square root of 7. And then I'm able to combine these numbers a little easier. In other words, okay, I still needed a calculator because I still need to multiply 12 times 7 times 7. So I did need a calculator that came up with 588, but I didn't have to do any strong math to reduce square root of 294. And that's a big advantage because, quite frankly, reducing square root of 294 is not easy. So what we're beginning to see is that sometimes it makes sense to reduce these right out the gate, even if you're not pulling an integer out. Notice that I reduced square root of 14 to square root of 2 times square root of 7. Well, normally I would never do that. The only reason it actually was beneficial in this case was that the square root of 21 is the square root of 3 times square root of 7, and now I can combine square root of 7 times square root of 7 easily. So it was actually helpful in this problem to do it, to simplify as much as you could first. Now, this one here is pretty easy. Hold on. I've got 11 root 8 times 2 root 8. Well, I can do this the first method. First of all, what's root 8 times root 8?
64.
Well, it's the square root of 64.
It would just be 8.
It would just be 8. In other words, the square root of x times the square root of x is always x. It doesn't matter. You didn't need to go to 64. You knew immediately that the square root of 8 times square root of 8 was 8. Now I've got 11 times 2 times 8. That's 22 times 8. And again, I may have to use a calculator for the final thing, but it's multiplication. You can do multiplication really easily on a calculator. It's not so easy to factor a number on a calculator. So if you can avoid having to factor some of these, you're better off. In other words, clearly this is easier if I don't make it the square root of 64. It's not necessary to deal with that big of a number. Look at 17. Square root of 27. Well, this is a very, square root of 27 squared. What's that going to be?
729.
27.
Oh.
In other words, the square root of any number squared, remember squaring undoes square rooting.
Yeah.
So that's always equal to x. So this is always equal to 27 without doing anything to it. I don't need to break it down at all. I could, in other words, I could turn square root of 27 into square root of 9 times square root of 3. And then I'm going to square that whole thing. Well, square root of 9 is 3. So now I'm going to do it this way. Well, that's 9 times 3. So I get to 27, but notice it took me 3 steps as opposed to 1 step there, and it didn't matter what the number was under the radical sign. Whatever it is, that's the answer. So notice how the first method is far superior to the second method. Next one, 2 root 13 squared. Now that square applies to the 2 and it applies to the root 13. So you have to square both of them. What's the first number squared?
4.
What's the second part squared?
It would be 169, which would come out to 13.
It's 13. Don't make that 169. That's an unnecessary step. In other words, the square root of 13 squared is 13. And now notice I get my answer without ever dealing with a number greater than 52.
Mm-hmm.
The way you were going to do it was 2 squared times the square root of 169, which is still 4 times 13, but I got to deal with this big number, 169. I may not know what the square root of 169 is. So whenever you're doing math, when you can keep numbers small as opposed to big, always do it that way.
Mm-hmm. Okay.
What's this going to be?
16 times 3.
Good. Not 48. What's this going to be?
25 times 8.
You know what that is off the top of your head?
200.
Yeah, if you have 8 quarters in your pocket, you have $2. And a lot of times when you're dealing with the number 25, it really makes sense to think about it in terms of quarters, because most people know how many quarters make what. In other words, if I said, if you had 7 quarters in your pocket, you should know that that's $1.75, right?
Mm-hmm.
Which means 7 times 25 is 175. So a lot of these 25 problems you can do just by merely thinking about it in terms of quarters. All right. 1 over root 3. What's the problem with that as an answer?
You can't have a square root on the bottom.
Yeah, that's an irrational number, square root of 3. Okay? It's approximately 1.71, but the numbers go on forever and never repeat. So it's an irrational number. We cannot write square root of 3 as a fraction. And math doesn't particularly like irrational denominators. So they rationalize it. How do I rationalize this?
You times both the top and the bottom by square root of 3.
Which gives you what? In other words, I'm allowed to do that because I can multiply any fraction by the number 1 without changing its value.
It would equal square root of 3 over 3.
That's the more proper answer. Same number. If you put this into your calculator, you'll get exactly the same number as if you put square root of 3 over 3 into your calculator.
Mhm.
Different numbers. The thing is, on the one on the right is I'm dividing by a rational number, and that's okay. I don't care if I have an irrational numerator. That's fine to have an irrational numerator. Just don't want irrational denominators. So the next one, 5 over root 10. Again, I have an irrational denominator.
So you would times both the bottom and the top by a square root of 10.
Okay, what does that give you?
5 square root of 10 over 10.
Now I can simplify that again. What's 5 over 10 equal to?
1/2.
So this simplifies to square root of 10 over 2 by merely dividing top and bottom by the number 5. Next one, square root of 20 over the square root of 9.
Would you times both the bottom and the top by the square root of 9?
Well, not really. You don't need to. The square root of 9 is not an irrational number. What's the square root of 9?
Oh, 3.
Yeah. So immediately it becomes that. And that's okay as an answer except for one thing. I can simplify the numerator.
Mm-hmm.
In other words, I can pull out a whole number out of that.
Yeah.
So what's the final answer? Factor 20.
It would be
Square root of 4 times the square root of 5.
yeah.
Only going to factor it if one of them is a perfect square number.
Mm-hmm.
And now that square root of 4 becomes a 2. So I end up with 2 root 5 over 3. And that's the answer. So you always want to simplify it as small as you can, except if I had square root of 10, I'm never going to write that way unless there's a reason for it. Because that is not simpler than that. That's 2 terms, that's only 1. So unless I can pull out a whole number, I don't do that. Or, as we've seen in some of these cases, if I can pull out a square root of 7 there and a square root of 7 there, I do it because I can then multiply those square roots by one another and get 7. So sometimes you do it, sometimes you don't. It kind of depends. So let's look at this next one. Now, clearly an irrational denominator. Problem is, what would be an obvious first step?
Times both the bottom and the top.
Yeah, even though that gives me some pretty big numbers, but not that big. So what's the top now?
8 square root of 30
Over
30.
Okay. Now I can certainly simplify that into what?
You could do 4 and 15.
Yeah, so 4 root 30 over 15. Now, that to me looks like it's completely simplified, because if I try to simplify root 30, what are factors? There are 30 and 1. There's no perfect square there. There's 15 and 2. There's no perfect square there. There's 5 and 6. There's no perfect square there. So I really can't do much more with that. And if I were to break it down into any of these, is all I would be doing would be the same thing if I said, is root 30 simplified? And the fact is, it is. I cannot find a factor of 30 that is a perfect square number.
Mm-hmm.
So I don't simplify it unless I can see a reason for simplifying it. Maybe if there was a root 6 in the bottom, I might split it up into root 5 times root 6, because then I could cancel out the root 6's.
Mm-hmm.
But the bottom doesn't have anything that's going to help me. Maybe, let me think about that for a second. What if I do this? 4 root 5 times root 6 in the top. In the bottom, what if I said 5 times 3? Well, now I can do something with that, but it's not particularly pleasant. It puts a root 5 in the denominator. I don't want irrational denominators. So that doesn't help. And I really don't, I might be missing something, but I don't see any way to simplify that answer. To me, that's the final answer. Might be missing something, but I don't think so. All right, let's see. Number 25. When you have the radical sign outside of the entire function like that, well, the very first thing I'm going to do is root 5 over root 20. In other words, that's always true. The square root of a over b is the square root of a over the square root of b. So you can always do this process. Now, how can I change the bottom so that I can simplify this a little bit?
Times both the bottom and the top by square root of 20.
Well, let's make it a little easier. Let's make the bottom this. Wow, and 4 is a perfect square number. So now I have square root of 5 over 2 square roots of 5. What can I do with the square roots of 5?
Cancel them out.
Leaving 1 over 2. Now, let's go back to the beginning. Square root of 5/20. Well, I can see that 5/20 is 1/4, right? So if I do that first, now I got square root of 1 over square root of 4. That immediately goes to 1/2. So it's actually a little faster to reduce that fraction before I do anything else. And as you can kind of see, some of these it's faster to do that first. Sometimes it's not faster. You just kind of have to be able to see stuff. But you're always going to come to the right answer even if you choose a path that's a little bit slower. You don't always have to have the fastest path. Allie, I'm sorry, but I have a 4 o'clock I got to go to, so I'm going to have to run.
Okay.
Okay, hopefully this will have helped you a little bit.
Mm-hmm.
All right. Talk to you.
Thank you.
And Tuesdays at 3:30 are good for you as a standard?
Mm-hmm.
Okay. Talk to you next Tuesday at 3:30.
Good. Thank you.